So, hi. So, in this series, we are try to focus more on the questions that are asked in the Amazon interview. Okay. So, we'll look at the questions. So, this is our first question. The question is rotate the matrix. So, the question is rotate matrix. Let me rotate matrix. So what we are given in the question, we are given an n into n 2D matrix. Okay. So this is a 2D matrix. Let's suppose 1, 2 and 3, 4. This is a 2D matrix and we have to rotate it 90 degree. So after rotating this 2D matrix 90 degree, so what will be the scenario? This would be the scenario if we rotate it by 90 degree. So this would be the scenario that means let me do it more clearly. This first row will become the last column. Look carefully. This first row will become the last column, and the second row second row will become, or we can say the last column will become, last row will become the first column. So that means the row is changed to column and their occurring sequence has been reversed, because in this original array this 1D array was at the first row, and in the rotated array it is at the last column. Okay, so row is changed to column and the first has changed to last. So how would we try to approach this question? One thing, it has also mentioned in the question, you have to do it in place. We look at this case also. First we try to solve it using a space. Okay, using an auxiliary space. So what we have 1 2, let's suppose we take a 3 into 3 matrix. Okay, so let us suppose we have 1 2 3 4 5 6 7 8 and 9. Okay, so these are 2D matrix. When we rotate it by 90 degree, what will be the scenario? The first row will become the last column. So it would be 1, 2 and 3. The second last row, the second last row, it will become the second last column. And this last row will become the first column. 7, 8, 9. This will be the 2D matrix after rotating the original matrix by 90 degree. Okay, so what we are basically doing, we are interchanging interchanging the and the columns rows and the columns. The first row in the original is becoming the last column in the rotated matrix. It has becoming the last column. So what we can do, taking an auxiliary matrix first, let's suppose we define it with 0 0. Every element in the 2D matrix is 0, but it is of the size of the original 2D array. So after doing this, we'll make our first row to be the last column in this matrix. We can do that. We can make the next row to be the second last column. We are starting from the end towards the front, so we'll make this columns as according to this row. Okay, and make this column according to this. So what is the time complexity and space complexity required to do this question using an auxiliary space? So let's suppose we are having m into n, or basically we are having n into n matrix. So the time complexity to traverse the matrix is order of n square, and the space complexity is also order of n square, because we are using an auxiliary array now. But it has been specified in the question that we don't have to use any auxiliary space. So now how can we try to solve this question? Because this approach, we can do it. We can absolutely do this approach, because what we have to do, we have to just take an auxiliary array just as of the size of the original array, make the last, starting from the end, make the last column as the first row in the original 2D array, make this next column in the rotated matrix as the next row in this original matrix, and the last row in the original matrix as the first column in the rotated matrix. So we can do it. We can absolutely do it. But this is not a this is not a optimized approach now, because we can definitely do it, but this is not an effective approach. So let me tell you a effective approach that does not require any auxiliary space. Just it requires your observation. So let's suppose we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, this is the 2D matrix we are given. What is the rotated version of this? This row will become the last column. 1, 2, 3. This row will become the second last column. We have 4, 5, and 6. This row will become this column, 7, 8, and 9. This will be our answer. Okay. So what we can do to solve it in place, we have to observe this. Okay, we have to observe this. As we can see, if we do transpose of this matrix, what will be the transpose of this matrix? Transpose is interchanging this value with this value with this value with this. Okay, so the row value is changed with the column value. This is what happening in 90-degree rotation. So this, if your concept of matrix are little bit clear, you would have observed it in one go. Okay, so because the rows are in the by rotating the original 2D matrix by 90 degree, the row are changed to column. And what happens in the transpose? The same thing happens. So lefting out the diagonal elements are not exchanged. So what will be a transpose of the matrix? So we have the transpose of the matrix as the diagonal elements remain the same. This diagonal element remains the same, but this element is changed to this. So we have 4 here, 2 here, we have 7 here, 3 here, we have 6 here, and 8 here. Okay, this is what we are left with after transposing the 2D matrix. Okay, we have found a transpose of this. So is it equals to our answer? Is it equals to our answer? No, it is not equals to our answer. So we can observe one thing. The row, the row, the row in the transposed matrix and the answer which we require, the row are the same. But we have to reverse this row. If we reverse all the rows in the 2D matrix, let's suppose 7 4 1 8 5 and 2 9 6 and 3. We have found our answer. If we rotate the individual row in the transposed matrix, we can get our answer, that is the 90-degree rotation of the matrix. So basically first step, if your concept of matrix are clear, you have observed this transpose thing. Okay, so first thing we are doing is taking a transpose of the given 2D matrix. First thing, if we found the transpose, we have to reverse the rows. Row by row, we have to reverse in the 2D matrix and we'll return. So take it step by step. So these are the steps. So we'll do first thing, we'll take a transpose. So how can we take a transpose of it? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. How can we take transpose of it? So basically we are swapping out the values. Okay. So what we can do, let's suppose an end-to-end matrix we are having. So the outer loop will run from 0 to n. Okay, the inner loop will run from I plus 1 I plus 1 to n. So let me tell you why I am doing this. Okay, because let's suppose let me write the whole code. Let's suppose the array name is A and we swap the ij with ji. So what we are doing, so let's suppose I is here and j is here, because starting out with 0 na, this is 0th row, 1 2, 0th column, 1 2. Okay, so we are at 0th row and j is at this, I is at this, j is at this. So we are swapping the value of this and we are swapping it with this. So this the index of this element would be a of 0 of 1, and what we are swapping it with, 1 of 0. We have swapped. So what will be our matrix? Here we'll have 2, here will we have 4 4 we have 4. Now we'll move in the loop. Here we have j. It will be swapped with this value, because what is the index of this value? We have 0 comma 2 and it will be swapped with 2 comma 0. So it will be this value. So here we will be having 7, and here we will be having 3. Okay. Okay, now if we have run the loop, if we have run this loop also from 0 to n, then after swapping this value, when we reach this value, we again have swapped the values. So at the end of both the loops, we're gonna have the same matrix, same original matrix that we have in the beginning of the question. Okay, so we have a 2. Now I will be here and j will start from 2, because I plus 1 at j start from I plus 1. So j is at 1, so it will be starting at 2 and this value will be swapped with this. So here we'll be having 8 and here we'll be having 6. Now we'll move to this. Now when we look at this row, we do not have the element to be swapped. So we have got the transpose of the matrix. We have got the transpose of the matrix. Our first step is clear. Our first step is clear. This is what the transpose of a matrix look like in the code. Now we have transpose. We have to reverse the rows. So it is very simple. Traverse the number of rows. Let's suppose at each row we'll apply a reverse function. I am writing it in C++. We can definitely write a manual function manually to reverse an array because it is basically a 1D array. So what we can do, we can apply in the C++, we can apply the reverse function and reverse every row in the 2D matrix. At the end, we don't have to return because it this will basically be implemented in the original 2D array. Okay, so this is the first question. It is a type easy question that is asked in the Amazon interview, technical interview. So if you have any doubt, so please feel free to ask, and bye.